Hello everyone. In the previous lesson, we learned the installation and adjustment method for the guide rail and reference surface. In this lesson, we will use the already aligned guide rail, referred to as guide rail 1, as the reference to adjust the parallelism between guide rail 1 and another guide rail, referred to as guide rail 2. Next, we will study the following content. Through this lesson, I hope everyone will understand and master the principles and methods of adjusting parallelism between guide rails, including preparation work, installation steps, and adjustment techniques. You will also learn to proficiently use vernier calipers, dial gauges, and other tools to measure and adjust guide rail parallelism, ensuring the parallelism error remains within 0.02 millimeters. Before starting the lesson, please recall the preparation work we studied in the previous session on the installation and adjustment of the guide rail and reference surface. Yes, it includes cleaning and washing components, as well as cleaning the installation surface. These are all essential steps to ensure precision in adjustment. Now, with this foundational knowledge in mind, let's proceed to the learning content on adjusting the parallelism between guide rail 1 and guide rail 2. Firstly, let's know about the preparation work and tool selection for equipment disassembly. This installation and adjustment task consists of preparation work and installation of linear guide rail 2. Similar to the installation and adjustment preparation for guide rail 1 and the reference surface. Before adjusting the parallelism between guide rail 1 and guide rail 2, all assembled components must be cleaned. Remove burrs, rust, machining chips, and oil stains from the parts. Use an oil stone and cotton cloth to eliminate machining burrs and contaminants from installation surfaces and reference surfaces. Referring to technical drawings, the parallelism error between guide rail 1 and guide rail 2 is specified as 0.02 millimeters. The parallelism adjustment process requires the following tools: metric hex key wrench, vernier caliper, dial gauge, magnetic gauge stand, and rubber hammer. The parallelism between guide rail 1 and guide rail 2 is referenced using the side surface of guide rail 1 as the reference surface. First, place linear guide rail 2 onto the base plate, ensuring that both ends rest against the guide rail positioning block. If guide rail 2 cannot fully rest against the positioning reference block due to fixed hole limitations, insert adjustment spacers between guide rail 2 and the positioning reference block. Use 8M4x16 stainless steel internal hex screws to pre-tighten guide rail 2. Important note: when pre-tightening the linear guide rail, ensure that the tail of the screws fully sinks into the counterbore. Otherwise, when sliding the slider, the screw tail will rub against the slider, potentially damaging the slider. According to the technical drawings, measure the required distance between guide rail 1 and guide rail 2. Use a depth vernier caliper to take precise measurements, adjusting the spacers between the positioning reference blocks of guide rail 1 and guide rail 2 to meet the required specifications. Then we go to the dial gauge installation. Attach the magnetic gauge stand to the slider of linear guide rail 1. Mount the dial gauge onto the magnetic gauge stand, ensuring that the gauge's measuring tip is perpendicular to the side surface of linear guide rail 2. Important note: when installing the dial gauge, loosen the screws on the magnetic gauge stand to prevent damaging the stand due to excessive force. Once the dial gauge is installed, slide the slider along linear guide rail 1. Observe the dial gauge needle movement as it shifts left to right, determining the direction of guide rail 2 deviation. Use a rubber hammer to adjust the guide rail 2 so its parallelism with the reference surface meets requirements. The adjustment method is identical to the parallelism adjustment process for linear guide rail 1 covered in the previous lesson. Finally, gradually tighten the internal hex screws, securing the guide rail onto the base plate and fastening the guide rail positioning device. Final thought exercise. Once the dial gauge is installed, slide the slider along linear guide rail 1. Observe the dial gauge needle movement as it shifts left to right. As the dial gauge needle rotates clockwise, analyze how guide rail 2 deviates. In this lesson, we studied how to use guide rail 1 as a reference to adjust the parallelism between guide rail 1 and guide rail 2. Through detailed step-by-step explanations and interactive learning, everyone has mastered the principles and methods of adjusting parallelism between guide rails. You have also learned how to use vernier calipers, dial gauges, and other tools to conduct precise measurements and adjustments. I hope everyone can apply this knowledge in real-world scenarios, continuously enhancing your technical proficiency.